Let's revisit our CalcEngine demo and update it to use classes and methods. Here we are in our CalcEngine program as we left it at the end of the last module. Remember, what we had done was create 4 parallel arrays. One with the left values, one with the right values, one with the opcodes for the operations we want to perform, and then an array to hold the results. And the way we created commonality across these arrays was that we said that, well, the first member of each array corresponds to the first member in every other array. Same for the second, third, and fourth members. A much better way to represent this idea of related values is to use classes. So let's go ahead and add a class to our project here. Now I'm going to go ahead and use the IDE's ability to create a class for us. All it's going to do is create a class file and put the class definition inside of it. All the major IDs support this concept, and they all pretty much do it almost the same way. All I'm going to do here is go to my package name, right, com.process to CalcEngine, right-click on it, say New, take Java class, and give it the name of the class. So let's call our class Math Equation. I'm going to go ahead and just tell it to go ahead and create it. And what that does is create a source file named mathequation.java and put a public class declaration inside of it. Right now, what I want to do inside of here is create fields for each of the values that I need to keep track of, right? So if I go back to main for just a second here, basically I'm going to create fields for left vals, right vals, opcodes, and results. Right, so go back inside of here. All I need to do is make the space to do that. Right, so first I'll do left val. So I've just made it a public double and called it left val, very similar to what it was called in the old program. Do the same thing for our right val, our opcode, and our result. So now I have the ability to store all those values together inside this one class. Let's head back to the main program. Now if we look at the main program, inside here there's this great big switch statement. And this is kind of broken in terms of the fact that the program has to know a whole lot about how these operations work. The reality is the program just wants to have the work done. So this switch statement could really be moved out of here, and let's move it into our class, and so we can wrap it up inside of a simple method, right? So I'm going to go ahead and cut that away, go back to my equation, and let's add a public method on here called execute. Notice that I've marked the method void, saying it doesn't return any values. And in fact, it's not going to take any parameters either. So I'm just going to go ahead and put the code block inside of here. What I'll do now is I'll paste that switch statement inside of this execute method. Now what I want to do now is just update it to work on its own values, right? So the idea is for the first one here, for A, I'm just going to get rid of the subscripts because I want to use opcode as declared inside the class. Same thing for result. I'm just going to make that result. Same thing for left vals and right vals. So I got my result equals left val plus right val. That's using all the members. Here up here on the opcode, I need to take that S off so it matches. Right, so now the opcode matches up as well. So I'm now using, in the case of A, all of my member variables. Opcode for the switch, then the result, left val, and right val. I'm going to do the same thing for all the different cases and the default down here. So now my execute method knows how to perform all the operations using the member fields. So now the next thing I need to do is go ahead and start creating instances of my math equation. Right? So I'm going to go back here to the main program. And what we're going to do is get rid of all these arrays up here. I'm just going to comment those out. And what we'll do is instead is create an array of our math equation class. So I'm just going to declare math equation, put the array indicator on there. We'll go ahead and call this equations and set it equal to a new array of math equation. Now we've created the array of math equation. Now that creates the array itself, but I still need to create the individual math equation instances for each array member. So what I basically need to do is say something like equations sub-0 equals new math equation, and then go through and set each of the fields, right? Left vals, right vals, and opcodes. Now since I'm going to have to do that 4 times, this is another great chance to use a method, right? I can use a method to kind of encapsulate all that work of creating a new instance and setting all the values. So I'm going to go ahead and create that here inside of my main class. Right? So I'm going to create a new method here. I'm just going to go ahead and call the method create. So I'm going to mark it as public. This uses a modifier called static that we haven't talked about yet. We'll talk about that one a little bit later in the course. Let's just go ahead and put it in for now. And what our create method is going to do is return back a new instance of math equation. So its return type is math equation. And again, we're going to call it create. And what it will do is accept a parameter for each of the fields we want to set, right? Left vals, right vals, and opcodes. And so we have all the parameters there. Let's just go ahead and put the brackets in place. So now what we're going to do inside of here is create a new instance of the math equation. So I'm going to declare math equation We'll call it equation, and then new up to math equation. So that gives us our instance of the math equation. And what we want to do, let me just scroll down here so we can see a little better. Right, what we're going to do is go through and set all of the fields to correspond to the parameters. So for left val, I'm going to say equation.leftVal equals left val. So it takes whatever that left val parameter is and sets the left val field on equation. We'll do the same thing for right val and opcode. With all the values set, the only thing left to do is return back our equation. So with that all set, what we can do is up here in the main part where we create each one, rather than explicitly create them, we can instead call that create method. So what I'll do here is just call create, and then pass in the values I want to use. So for left val, on the first one, I'll use 100.0, then I'll use 50.0, and then the opcode D. And I'll do the same thing for the other three members. So now we have our math equation array created, and then we also have the individual math equation instances created into each one of the arrays. So I'm going to go ahead and get rid of this for statement here. We don't need that one anymore. What I'll do here is that where we have this for each, where we're going through the results before, what we can do now is go through that math equation array. All right, so I'll go ahead and declare it as math equation. I'll call the variable equation, and what it will loop through is equations. So now what I can do inside of here is for each one, I can simply say equation.execute. What that'll do then is when I call equation.execute, right, for each of those sets of values, it'll go into math equation, call execute, check the opcode, perform the appropriate operation, store that in result. So when I get back here, what I can do then print out is simply equation.result. And so now I have a much more encapsulated application here, right? In the sense that I have the idea of what I want to perform modeled into my class math equation, right? So it has the fields for each of the things I need to perform the operations. The execute method does the actual work. If we go back to the application doesn't care about any of those kinds of details. It simply creates each math equation instance, loops through them, tells each one to execute, and then displays the result. So if we go ahead and run this, we get our appropriate results out, right? Is that 100 divided by 50 is 2, 25 plus 92 is 117, 225 minus 17 is 208, and 11 times 3 is 33.